Hi everyone, my name is Yuri. I've written there my name, my family name, my email address, whitebuddha, yburda@math.uc.ca, and the website for the course is sites.google.com/science/whitebuddha/math, small dash, and 110. So most of the important information for this course is going to be posted on this website. We'll have maybe lecture notes, definitely lecture videos, and try to record most of the lectures, and I'll post them on the website. On the website we'll have the rating scheme, we'll have assignments posted there. So basically all the information about the course is going to be on the website. Another important thing, if you want to ask a question, and it's really a good idea to be asking questions during the term. We'll have lots of material, lots of exercises, and some will be more clear, some will be less clear. Sometimes you want to verify something, you want to ask how to solve something. So when you want to ask a question, well, one option is to send me an email. So that's a test paper. Another option is Piazza. So it's an online form for our course. The registration link is once again on the website. So if you go there, you'll find the link to sign up to Piazza. And there you can write down extra formulas like square root of 5 minus x. So it will display in a nice way like square root. And it should be pretty convenient. And it's, well, you ask a question and everyone has an option to answer it. Me and the other instructors will be checking Piazza regularly and they'll be posting our answers there. And if one of you posts an answer, they'll go over it and see if it's correct. If it's correct, they'll put the check mark on it and you can go and this answer as well. Okay, so other things, once again, administrative stuff. We'll have okay, so the grade for the course will consist of the following components. We'll have two final exams, one in December, one in April. They are the largest component of the mark, a total of 45%, 20% for the December one, and 25% for the April one. We'll have homework assignments. So we have two types of homework assignments. One will be short online questions called web work. There you just have to basically write down the answer and you do it online. You need to report it once again there. We have the first web work next week. We also have a little bit longer questions which you have to hear in. We'll talk about writing down proofs, writing down explanations, so longer questions. So the web work and the assignments are going to account for 15% of the grade. Then we have 5% of the grade for skills modules. It's basically a total of 120 questions which will be assigned over the term. And the sole purpose of it is to make sure that everyone remembers high school material. So it will be just simple exercises like open the brackets, simplify the whole expression. But there will be a lot of them, and the purpose is for everyone to be pretty good at simple algebra, simple high school algebra. So it will count for 5% of the mark, and it will be assigned online. We have plenty of time to do this. So homeworks. Oh yes, and midterms. We have one midterm in the winter, one midterm in the spring, and this will report later. Okay, so, oh yes, another thing, I have hold office hours on Mondays and Thursdays, I believe. The exact time and exact date, exact place is posted on the website. If you have any questions, once again, several options. Either ask it online with the help of Piazza, or ask it by email, or come to the office hours, or if you can't make it to the office hours, send me an email and schedule the meeting. Okay, so maybe any questions about just the administrative part of the course? We haven't touched on any kind of math, any kind of material, just the administrative part. Okay, so before we go to the actual math, about actual calculus, let me talk a little bit about, well, you come here, it's probably your first or one of the first math courses at university. You might have some experience with high school math, and it might have given you some idea of whether you're good at math, whether you're bad at math. So I want to, well, to know a little bit about this. So I want to ask you, how many of you think that you are good at math? Okay. How many of you think that you are okay with math? Okay. How many of you think that you are bad with math? Okay. So what I want to say is, it's kind of a trick question. It's not really a useful concept to have in mind of whether I'm good at math or bad at math or even okay with math. And the reason is, well, there are two reasons. One reason is, well, it's not really useful. I mean, let's say I know that I'm good at math and I encounter a topic that I never seen before, and from the first attempt I kind of can't understand it. Well, what should I do? Should I kind of say I'm still good at math, but this topic is not really my kind of math, or persist, or what should I do with it? It's even worse if you have the self-concept of being bad at math, because then, well, everything I'm going to teach is, well, how is it relevant? I'm bad at math, so I won't even try to make the effort. And both things are not good. A much better idea is, well, to have the concept in mind that, well, I'm good at making an effort. And it's really important to, well, be proud of just making the effort. And what does it mean to be making the effort? So in this course, the minimal amount of effort that you just have to make in order to obtain the grade is prepare for the midterms, prepare for the finals, do your homework, submit all the homeworks. Well, attending the lectures is not part of the mark, but it's a good idea, it's helpful. The workshops. 15% of the mark is for the workshops, so you should be registered in one of the workshops. It's a good idea to be there, because basically most of the mark is just for attending the workshops, and it's really a good idea to, well, pay attention there. You will be solving problems there in small groups, you have discussions, you will be applying concepts that you learn here, so do go to the workshops. That's kind of the minimum. So it's part of the things that you have to do in order to obtain the grade. Otherwise, well, it won't come to the grade. Besides this, it's a good idea to try to solve, so we have a list of suggested problems. It's a good idea to set aside every week, or maybe 3 times a week, or whatever schedule is convenient for you, some time to just study. Maybe it's a little bit one day before the lectures. Let's say, maybe Sunday evening is not the best time, but Tuesday evening and Thursday evening, set aside half an hour, 1 hour to review the material of the lecture, to see whether you can solve the exercises. And another good idea is, well, to strive for mastery of the concepts. So let's say today we'll learn something about lines, something about equations of lines. I assume that some of you don't know this material, or have learned it but already forgot it, or something like this. Well, there are several types of exercises which are pretty standard about this material. Let's say find the equation of line passing through 2 points, or find an equation of line which is parallel to a given one and passes through a given point. So at first, like after this lecture, in this lecture we'll only cover the concept. What is the equation of line, how to find it in very simple situations. The suggested problems will be actually asking you these particular types of questions which you should master. And you should expect that the first time you attempt them, well, you might not really succeed. It's okay. So the first time you attempt to find an equation of a line which is parallel to a given one and passes through 2 points, you might recall that you heard something about equations of a line today in the lecture. Well, it's already good. If you recall that there was something somewhat similar, it's a good thing. Then you will review the lecture, you will find that we actually talked about the concept of slope, about the concept of parallel lines. Then you'll go to the first exercise, and armed with these concepts, you will actually, after some effort, you'll succeed solving this exercise. Don't stop there. Just one exercise which you solve successfully is not going to be enough to kind of consolidate this mastery, this skill. You have to solve a couple more exercises, all the same difficulty, all the same type. Once you solve those, well, it will become more or less like, I don't know, like riding a bicycle. You know how to do it, you might forget the details, you try it once again for the exam, you know, you made it. So, do enjoy this. Yes, and it is actually enjoyable once you actually master some concepts and you see an exercise and it asks you, well, find an equation of the line which is perpendicular to a given one and passes through a point, and you just know how to do it, you are not scared of it, you actually know where to begin. It's really enjoyable. So that's the general things about just learning. Okay, so once again, maybe any questions? And of course, well, if you have a different style of learning, I know something that actually works for you and you know that it works for you, go ahead. Okay, so now to the math. So in this course we are going to talk about calculus. It's something that was invented in the 16th century by people like Newton, and the reason they invented it was because they wanted to understand the nature around us, how planets move, how stuff falls to the floor, how objects move. It turned out later that calculus was also quite useful for other things, for geometry, for finance, for, well, more recently for biology, for basically all kinds of sciences. And it turns out that the concept that you are going to learn here, like the concept of derivative, is going to appear, well, in all kinds of situations. So when you study, I don't know, finance, continuous interest, you'll find derivatives, you'll find integrals there. If you study electrical engineering, or if you study physics, or if you study biology, everywhere in different situations, the same concepts will appear. Same things, derivatives, integrals. So eventually we'll try to understand just the concepts. We'll talk a little bit less about the applications. We'll have some applications, but they will be not kind of domain specific. It will not be applications to finance, so it will be some simple applications from all over the place. And by the end of this course, this particular course, I hope we'll know everything about functions of one variable and derivatives, so rates of change, such things. So now let's start the actual material of the course. We'll start with drawing some pictures. So I hope that everyone has a sheet of graph paper. Is there anyone who doesn't have a graph paper? So there should have been some extras.
Jimmy.
Oh, that's when she actually
Arts. I'm guessing most people interested in arts. Or maybe science. Well, I don't know. Maybe science.
Okay, so we'll now talk about something that was discovered a little bit before calculus. It was discovered by Descartes, the French mathematician. What I want you to do now is, well, we have this brown paper, a small cross somewhere in the middle. Just a small cross. Small plus at least. Okay. Now I want you, so yes, another thing, it is usually a good idea to work in small groups on assignments. It helps you, well, when you explain concepts to other people, it helps you to understand it themselves. So, yourselves. So, we'll start working in small groups right now, so please find a partner or maybe two partners. If you can't find just one. Pair up.
My problem is that
please choose in each pair or in each triple one person who will be number one. So just in each small group there should be one chosen person, and I'll give assignments separately to this chosen person and to the rest of the group. Okay, so now I want the chosen person to put another dot somewhere on the paper. So only the chosen people in the groups. So only one person in each group puts one on this paper. Okay, so now the actual assignment. So this was the easy part. The actual assignment is like this. I want this chosen person to cover his dot and to try to explain to the rest of the group, whether it's just one neighbor or two people, where this dot is positioned. And what I want to achieve is for this explanation alone to be enough for the other members of this group to reproduce the dot at the same place. So at the same place relative to this cross.
No, I didn't. Okay, well, anyway,
So once you're done communicating, you might try to actually compare the two sheets of paper. Just take one of them and the other one and compare whether the dots are the right place.
okay, so it is just coordinate.
Because I have this
Right, so how many of the groups
the coordinates you're beginning point.
communicate the location of the dot? I would say most of the groups. So let's ask for the methods. How did you communicate? So, any volunteers? Yeah. Say again? Okay, so what she said was 8 over and 12 above, so something like this. From this cross, you take 12 steps to the right and 8 steps up, something like this. How many? Well, did anyone come up with some different idea? Some, well, maybe the same numbers, well, different numbers, but same idea, well, something to the right and something up is one idea. Did anyone have a different one? X-axis, Y-axis. So you actually drew some axis, something like this. And then what?
Like 12 on the X and 8 on
Okay, so it's basically the same idea. Instead of calling it right and up, we called it X direction, Y direction. Okay, yeah. Any other ideas? Yeah.
The same thing we did rise over run.
Okay, so basically the same thing. So rise over run. Okay, so yes, most of you did come up with this idea of coordinates. So once you have a reference point, which we'll usually call the origin. So once you have a reference point on your sheet of paper, and you also have some natural kind of orientation. So you know where is the right and where is up. And on the graph paper, it's very convenient because it's actually, you have these lines, horizontal lines and vertical lines. You can refer to position of any other point. So if I want to find a point here, I don't have to, well, to actually show a picture to somebody. I can communicate over the phone. I can communicate via email. I don't have to actually show a picture via email, but you can actually show a picture. You just have to tell how it is positioned relative to this point, and what most of you did is say it's positioned so many steps to the right and so many steps up. Or if it's not to the right and up, you'll say to the left and up, or to the left and down, something like this. So that's one of the ideas that, well, people came up with in order to refer to points, let's say cities on a map, or I don't know, a street in a city, a particular corner in the city. You refer to it by, well, its position relative to some origin. And usually we have such a picture. We draw two lines for the horizontal direction and for the vertical direction. For some reason we call this x-axis and y-axis. I'll talk about this in a second. And we say that this is our reference point, and if you want to find the point, location of the point, you draw a grid somewhat like the one you have on this graph paper. And let's say if you want to describe the location of this point, you say that it's actually 3 steps to the right of the origin, 2 steps up, and you say that it's described by these two numbers, 3, then 2. We usually refer to horizontal displacement first and vertical second. Or let's say, if I want to talk about this point, well, I'll have to go 1 step to the left, kind of opposite to the direction of this arrow. So say it's -1, and then 2 steps down, which is -2. And we have this idea, well, it's not something that we needed a great philosopher like Descartes to discover. It was known since, I don't know, ancient Greeks. They did have maps, they did have notions of longitude and latitude, they did refer to cities by how far they are located from each other on the horizontal direction and vertical direction. It actually felt that they thought that the earth was flat. Now we go a little bit better, so next a little bit more complicated. We have this kind of vertical lines, meridian, whatever, compared to the North Pole, but for them it was simpler. And of course you are familiar with this from actually living in a city like Vancouver. The map of Vancouver basically looks like this, with 4th Avenue, 5th Avenue, 6th Avenue, and streets like McDonald. So if you want to refer to a certain location, certain intersection, you say that, well, I'll meet you at the intersection of 5th and McDonald. So it's an idea which is very familiar. Next idea is, well, now we know how to refer to any point in the plane. Next, I want to repeat this exercise, but not with a point, but with a line. So the next group exercise. So choose some other person in this group. Well, if it's a pair, then the other person. And this other person should draw some line passing through the origin. And the task is, once again, communicate which line you drew. It could be such a line, such a line, such a line. Try to communicate what is the line.
We're now the chosen one. I've been promoted. I'm not reading. For my left. Okay. I wasn't sure. I felt like I just wouldn't guess. So if I can make it, we can just, it's not like, I don't know what to say. Okay, I'm just doing it. Max trade.
So once again, try to compare the original picture with the reproduced picture, and how many of you did succeed? Okay, now I'm curious, in the groups which did not succeed, which reproduced the line which is not the same or did not reproduce the line, what kind of problems did you encounter? So, was there anyone who did not succeed? Oh, great. So, in the groups which did succeed, how did you communicate? So let's say I'll produce a sheet of graph paper, and I also want to reproduce a line. So, yeah. Slope of the line. What is a slope? So, tell me, what should I do?
So she wants to slope to 1, so we do that for every number that was going to the right, you have to go up.
Okay, so what I heard was for every time I go one step to the right, I should go one step up. So I guess it's this line. Did anyone have a different idea? Yeah.
He gave me a point that it passed through, and I found the value was asked.
Okay, so give me a point.
2, 3.
2, 3. So a different line was given by such condition. You choose a point in the plane, and we know how to describe a point, and we draw a line. We know there is exactly one line passing through the point. Any other ideas? Yeah,
The 2 endpoints.
the endpoints.
You usually want to the origin and get to 2 endpoints.
Can you help me draw the same line?
Sorry?
Can you help me draw the same line?
Yeah, so we had like, so he gave us the 2 ends, so like 2 and 4, and -2 and -4.
2 and 4, and -2,
And we
-4.
go down to the origin.
Okay, and okay, so 3 points. Origin, one given point, and another given point. Any other ideas? Yeah.
Y is equal to X,
Y is equal to X. So
which is basically
only
first line.
I draw only the points where the Y coordinate is the same as X coordinate, so it's probably this line once again. Okay, so all great ideas. Let's discuss which of these ideas will work, which are the most standard ones, what are the advantages and disadvantages. So let me start with the idea of choosing a point on the line, or 2 points on the line. It's really a great idea because we know already how to describe a point in the plane, and we know that if we have 2 points in the plane, just even without the origin, like just 2 points in the plane, we know there is a line passing through these 2 points. So one way to describe a line is just to give 2 points in this line. There is a small disadvantage to this method. It's really a good method, but a small disadvantage, it's not really convenient when you want to describe, well, 2 lines and compare when the 2 lines are the same. Let's say, well, you communicate over the phone, and somebody tells you, so here I have a line through the point 0, 0, and point 4, 6. So you draw one line. Then you call once again, and you're given another instruction. Here's a line, and it passes through point 6, 9. So we go 6 steps to the right, and 9 steps up, and you find this point. And now you take a ruler, pass a point through the origin of this one, and well, it looks more or less the same line. It's not quite obvious whether it's exactly the same line. You might do some computation and see whether it is. But it's not immediately obvious. And it would be even worse if the 2 lines did not pass through the origin. You might give 2 points like this on this line, and then you might give 2 other points give also on the same line. You have the same line, but the description will be quite different. A different set of 4 numbers. So it's a good idea to give points on a line, but it produces, well, descriptions which depend on the choice of points. So not a standard description of this line. Another idea. Let's describe the line using its slope. So what is the slope? It's exactly this idea of once you make a step to the right, how many steps up will you be making? So if I have a line, and for now let's just think about the line through the origin, how can you describe it? Well, here's one option. If I make just 1 step to the right, how many steps do I make upwards? Well, now if I have 2 different descriptions, if I have different numbers here, I'll have 2 different lines. Or if I have the same line, I will always produce the same description. So given a line, I can just find its slope. It's a number and describe this line uniquely. So if I tell you that for every 1 step to the right, you make 2 steps up, the line has slope 2. And here's the line. So the concept of slope is for so the line has slope m if for every one step to the right, you move So the slope describes how steep is this line. If you want to move along this line and you want to make an advance of one step to the right, how many steps up you have? And let's have some examples. Let's say here's a line of slope 2. One step to the right reduces 2 steps up. A line of slope 1. Slope of -1. So one step up produces one step down. So we say that it's slope -1. Slope 0, how slope 0 looks like. Horizontal line, right? So this is slope 0. One step to the right and no vertical movement. So basically, if we give just one number, the slope, and we know the line passes through the origin, we know what the line is. Okay. So that was a second idea of how to describe the line. Now, how do these ideas connect? Describing the line by a point on this line and by its slope. Let's say I have a line of slope 2. So it means once I make one step to the right, I make 2 steps up. I want to describe it by giving a point on this line. So I choose a point. If I want it to be on this line, well, we have some coordinates. Let's say x and y. This has slope 2. So what can we say about this x and y? How do I know that this point is actually on this line? Is the point, I don't know, 1, 3 on this line? Well,
The y is twice the x.
exactly. So every one step to the right, I make 2 steps up. If I make x steps to the right, I'll make 2x steps up. So this point will have coordinates x, 2x. So the y coordinate is actually 2 times x for every point in this line. So if I give you a point, just any point, 3,7, and I ask you, is it on this line? There is just one thing you have to check. Is it true that y coordinate is 2 times x? So is 7 2 times 3? No. So it's not on the line. But 2,6, yes, it is on this line. So we already have our first simple result. A line through the origin of slope m can be described by the equation y equal to mx. Every one step to the right produces m steps up, so y coordinate is related to x coordinate by this equation. Y is m times x. In this example, m is 2. In general, of course, for any slope. So examples, slope 2, y equal to minus x, the slope -1, here we have -1 times x, y equal to 0, with the slope 0, y equals 1/2 of x, slope 1/2. So here we have all these lines. Slope 2, slope 1, slope -1, slope 0. I think we have slope 1/2, so let's reduce 1/2. One step to the right, half of one step up. It's more convenient to say that if I make 2 steps to the right, I'll make 1 step up. So we can easily produce another point. So here's a line of slope 1/2. Okay, so now we are quite proficient with describing lines through the origin. We have several options. One option is to give a point. Say, I want to describe this line and tell you the point is 2 comma. Another option is slope. For 1 step to the right, how many steps up do I make? And we have a way to convert between the two things. If you have a slope, you can write the equation of this line. Every point of this line satisfies the equation. Choose x, it will produce y. So if I want a point on this line, I will choose any x, 5, y will be 10. So here's the point on this line, 5, 10. Okay, and let's jump just 1 step forward. Why do we keep talking about lines which pass through the origin? Let's talk about lines which do not pass through the origin. I mean, most lines do not pass through the chosen point. You just choose a point somewhere in the middle of the paper. Chances are it's not on your line, on the line you're interested in. So, what ideas do we have? I want to describe a line which does not pass through the origin. Well, I employ the same ideas. Either choose a point. Well, now I can't choose just 1 point. 1 point is not enough. If I have a point, there are lots of lines, all passing through this point. I'll need 2 points. So either choose 2 points, or maybe describe it using the slope. Instead of choosing 2 points, choose 1 point and the slope. So choose a reference point, which we'll describe, and then the slope. Okay, so let's work with this idea of describing the line by a point and the slope. Let's say I want to describe a line which passes through a point, so line 2, 1 is slope 3. How do I know whether a given point actually lies on the point, on this line? So first of all, it's not hard to draw this line. I find the point 2, 1, 2 steps to the right, 1 step up. The slope 3, which means for every 1 step to the right that I make, I'll make 3 steps up. So from here I make 1 step to the right, 3 steps up. Connect these two things by line. So here's the line. Now, my next question, I give you a point, once again, 3, 7, or 5, 10. Is it on this line? How do I know? So if I give you a point with coordinates x, y, how can I know that it actually lies on this line? Yeah?
The y is 3 times the x.
Okay, y is 3 times the x. That would be the case if the line actually passed through the origin. So if I were talking about this line instead, slope 3 and passes through the origin, then I know that the y, the rise, as you know, is 3 times the run, 3 times the horizontal displacement. But here, I don't want to start at the origin. I want to actually start right here, at the point 2, 1. So it's not quite the y, which is 3 times the x. It's the displacement from this point. So this distance is 3 times this distance. So it's this divided by this, which is equal to 3. So this is the, as you said, rise, and this is the run. So the vertical displacement from this point is 3 times the horizontal displacement from this point, which is just saying 1 step to the right produces 3 steps up. Some, well, t steps to the right produce 3t steps up. Well, but what is this thing? The run is, well, how many steps did I move from the point 2 to the point with coordinate x? Oh, it's just x minus 2. So how many steps do I have to make from the point with coordinate 2 to get to the point with coordinate x? Just x minus 2. Because x plus 2 plus x minus 2 is exactly x. The rise, this distance, how many steps up did I make from the point 1? So if I started here at 0, I would make y steps up, but I started at height 1. So it's just y minus 1. And what I know is that the run is, sorry, the rise is the slope 3 times the run. So the vertical displacement is 3 times the horizontal displacement. So here's how to check whether a point lies on this line. Y minus 1 is equal to 3 times x minus 2. So now I don't need the picture anymore. If I want to ask over the phone or in SMS or something like this, whether a point 5, 10 lies on this line, so is, let's say 5, 10 on this line. I don't have to make a computation. Sorry, I don't have to look at the picture. I just have to check this one thing. Is it true that 10 minus 1 is actually 3 times 5 minus 2? Okay, it happens that yes, it is. So it is. So 5, 10 is on this line. So now we know how to describe any point on the line if we just know one point on the line and its slope. So next time we'll continue with this idea. We'll describe lines by 2 points. And so,